Okay, so for section 3.5, we're going to start talking about a least common multiple. You have to know what this is. They're also going to call it some other things, but they call it the least common multiple or the LCM. The least common multiple is something that's bigger. A factor is something that is smaller, something that makes up the number. The least common multiple is something that's bigger. Multiples are always products from multiplying that number with other integers or counting numbers. The least common multiple is the smallest of all the larger numbers that the two numbers have in common when listing multiples. We're going to talk about some of that down here, so don't get carried away or worried. If you need to pause it to copy stuff down, you can. It's not extremely important that you get all of this down because you're not going to be asked about this a lot, just maybe once or twice. Don't fret over it. But the least common multiple is in it. It's in there. You do need to know about it. So there's that. Changed the color on you, huh? Sorry about that. Let's see if that gets a little bit sharper. So I tried to zoom in a little bit, and this is what happened. So when we're trying to find least common multiples, I'm going to show you the easiest way to do it that tends to work every time. The first thing you need to do is find the prime factorization of all the numbers. So my number here is a 27, and then I have a 30, and then I have a 42. So when I find the prime factorization of 27, I start with all the prime numbers that go into 27. So 2 doesn't go into 27. 2 is the first prime number. We had a list of prime numbers earlier, so you can go back and refer to that list if you want to. So 2 doesn't go into 27. 3 does. So I'm going to say 3 goes into 27. 3 times 9. Since 3 is prime, I'm going to circle it. And then I'm looking at things that go into 9. I've already ruled out 2 because 2 didn't go into 27. So now I'm back to 9. What does 3 go into 9? And yes, it does. Even though it went in to 27, I have to keep trying it until it runs out. So 3 goes into 9 3 times. So I have all primes now. I know that because everything is circled. So that means 27 is 3 times 3 times 3. And I'm going to write them out so that I can see them all. 30. 2 goes into 30. I try to do things systematically. 2 goes into 30 15 times. 2 is prime, so I'm going to circle it. 2 does not go into 15. 3 does. 3 times 5. Both of those numbers are prime. So that makes 32 times 3 times 5. Then I look at 42. 2 goes into 42 21 times. 2 is prime, so I circle it. 2 doesn't go into 21, but 3 does. 3 goes into 21 7 times. Both of those numbers are prime, so I get to circle them. So that makes that 2 times 3 times 7. So you remember how when we were doing things like you had to have one on top, one on bottom, and it would cancel stuff out? I'm kind of sort of going to do that when I start listing numbers down here for my least common multiple. So if I find it up here anywhere, I can cancel it out in the other ones. The other ones don't have to have the number, but if they do, then I get to cancel it out. So I'm going to start with this 3 right here. Since I have 1 3 here, if I see it anywhere else, I can cancel it out. 1 3, 1 3. They get canceled. I get to write down 1 3. I have another 3. If I had another 3 anywhere, I could cancel it out. I get to write it down. I have another 3. If I had another 3 anywhere up here, I get to cancel it out. I don't, but I do get to write it down. Then I go to the next number. I have a 2. If I had a 2 anywhere up here, I'd get to cancel it out. So I have one over there. I get to write it down. I have a 5 up here. If I had a 5 anywhere else, I'd get to cancel it out. I don't, but I do get to write it down. And then I have a 7 up here. It's the last number that I have. And I get to write it down. So now my least common multiple will be this number right here. So if I would have listed out all the numbers that are multiples of 27 and all the numbers that are multiples of 30 and all the numbers that are multiple of 42, the first one where all of them would be this number right here. Instead of listing them all out, I'm just going to multiply out this number and get 3 times 3 times 3 times 2 times 5 times 7 is 1890. Now that's all fine and good, and that's great. I found the least common multiple, but a lot of people are still like, what the heck is the least common multiple? I don't understand. So let's think about it a different way. Let's say we were talking about numbers like 2 and 3. If I wanted to know the least common multiple between these, 2 doesn't go into 3 and 3 doesn't go into 2. So it can't be either of those numbers. I would list out numbers that 2 goes into. So multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14, so forth and so on. Keeps on going, long ways, forever. Keeps on going. If I were to list them out for 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, so forth and so on. Keeps on going. Common multiples would be numbers that they have in common, like 12. They both have a 12. The least common multiple is the smallest number that they have in that list in common. So my least common multiple is 6. If we could do it like this for these great big numbers, we could, but it would take a long time for us to get there. So there's a shortcut. I showed you the shortcut. When you get great big numbers, use the shortcut. When you have really teeny tiny numbers, you can do it the old-fashioned way. Okay? Sorry. Long way. Shortcut. Shortcut for big numbers. Old way. Okay. One for you to try. $36, $45, $60. Two goes into 36 18 times. 2 goes into 18 9 times. You don't have to do it the way I do it. You just got to get the numbers that I get. 9 is 3 times 3. So that's 2 times 2 times 3 times 3. 2 doesn't go into 45, 3 does. That's 3 times 5. Two times 30 2 times 15, 3 times 5, so I start here, I cancel out 1, 2, this one doesn't have any 2's, this one has a 2, so I can cancel it out. I get to write down my 1, 2. Start here, cancel out 1, 2, this one doesn't have any 2's, this one does, so I can cancel it out, and I get to write down my 1, 2. Start here, cancel out my 3, get to cancel out a 3 here, get to cancel out a 3 there, and get to write down a 3 down here. Just 1 3 because that's all we were taking care of. Start here, get to cancel out a 3, get to cancel out a 3 here. This one doesn't have another 3, but I do get to write down my 3. No more numbers here. Start here, get to cancel out a 5, get to cancel out the 5 there, so I get to write down my 5 here. No more numbers here, no more numbers there. So this will be my answer. 2 times 2 times 3 times 3 times 5 equals 180. If you want to find it using letters, you do it the exact same way. You list out your letters. Once you take care of the numbers like we did here, you would list out your letters right beside it. Just like we did before, listing them all out up here, and you take care of them just like we did the numbers, and they come down here. They get added up with the exponents there, just like we would normally. Works the exact same way. Finding equivalent fractions. You can multiply any fraction by any non-zero number as long as you do it on top and on bottom. So you can multiply by c over c because c over c is the same thing as 1. So it's like multiplying by 1. So you can change a over b to ac over bc. Means the same thing. It would reduce down. Everything's fine. So 2 over 5 in essence is equal to 6 over 15. It just needs to be reduced. They want you to find the LCM of 6 and 10. 6 would break down to 2 times 3. 10 is going to break down to 2 times 5. So my LCM is going to equal 2 times 3 times 5, which is 30. Here you have 3 times 2 times 2 times 2, which is 24. I don't think they'll ever ask you that. So 14, 35, and 49. 14 is 2 times 7. 35 is 5 times 7. And 49 is 7 times 7. In case you hadn't noticed, one of these, 2, will be written down once. The 7 is going to be marked out all the way across. Then you'll have a 5, and then you'll have a 7. $490. So the one with the letters. 24 XYZ 16 xy squared, and then 6 x squared z. For the 24, we have a 2 times 12, 2 times 6, 2 times 3. That's going to give me 2 times 2 times 2 times 2 times 3. Oh, sorry, I got one too many 2's in there, don't I? Times x times y times z. Because I got to put my letters in there too. For the 16, 2 times 8, 2 times 4, 2 times 2, 2 times 2 times 2 times 2 times x times y times y. And then for the 6, we get 2 times 3 times x times x times z. So my LCM is equal to, I got a 2 here, got one there, got one there, which means I can write a 2 down there. I got another 2. I don't have one there, but that's okay, I can still write it down. I got another 2. That's okay, because I can write it down. I got a 3. None of them here, but I got one there, and I can write it down. I got an X. I got an X here, and an X here, and I can write it down. I got a Y, and a Y here, no Y there. And I got a Z. No Z here, but I got a Z there. Okay, so that took care of this number. Now I'm to here. I still got a 2. And no 2's there. No other numbers there. Back over here, I still got a Y. I'm out of numbers, though. And over here, I'm out of numbers, but I still got an X left. So I have 1, 2, 3, 4 2's. And a 3. That's 48. And then I've got 2 X's. One here, 2 Y's, and 1 Z. There we go. You won't be asked to do it much, but you are asked to do it once or twice. They want us to come up with the missing number. So here, what do you multiply by 8 to get to 24? You had to multiply by 3. If we multiply by 3 up here, then that means we had to multiply by 3 on top, which means it's 15. Here, what do we multiply by 16 to get 80? Well, that's times 5. So we have to multiply by 5 up here. Negative 3 times 5 is negative 15. Don't forget the x, because it doesn't go away. Okay, we'll see you in the next section.